Hello wonderful peoples. Welcome to Wings of Cosmos. Today we're gonna discuss about water as fuel of satellites developed by NASA. Let's begin. A NASA CubeSat will launch into low Earth orbit to demonstrate a new type of propulsion system. Carrying a pint of liquid water as fuel, the system will split the water into hydrogen and oxygen in space and burn them in a tiny rocket engine for thrust. NASA's Pathfinder Technology Demonstrator, or PTD, series of missions demonstrates novel CubeSat technologies in low Earth orbit, providing significant enhancements to the performance of these small and effective spacecraft. The first mission of the series, PTD-1, is already launched this month, aboard a SpaceX Falcon 9 rocket on the Transporter-1 mission, from Cape Canaveral Space Force Station in Florida. We have a driving need for small spacecraft propulsion systems. The need is for many reasons: to reach a destination, maintain orbit, maneuver around other objects in space, or hasten deorbit, helping spacecraft at end of life, to be good stewards of an increasingly cluttered space environment. This addresses a major concern, as spacecraft can become orbital debris at the end of their missions. The longer defunct spacecraft stay in orbit, the greater chance of spacecraft-to-spacecraft collision, creating more debris. Water as fuel. A small metal unit on a wide table. This Hydro's hardware unit is a water-based propulsion system, sized for CubeSats. The system uses electricity to produce gas propellants, hydrogen and oxygen, from liquid water and burns these gases in a rocket nozzle to generate thrust. This technology will be demonstrated in space during NASA's Pathfinder Technology Demonstrator-1 mission. Hydros was developed by Tethers Unlimited Incorporated, in Bothell, Washington. The choice of fuel used in spacecraft propulsion systems can come with serious safety precautions. Traditional, high-performance fuels pose risks, including toxicity, flammability, and volatility. The use of such rocket fuels for in-space propulsion systems require extensive safety measures, and this drives up mission cost. To make these propulsion systems feasible for CubeSats, good propulsive performance needs to be balanced by safety. PTD-1 will meet this need with the first demonstration of a water-based electrolysis spacecraft propulsion system in space. PTD-1's propulsion system will produce gas propellants, a mix of hydrogen and oxygen, from water, only when activated in orbit. The system applies an electric current through water to chemically separate water molecules into hydrogen and oxygen gases, in a process called electrolysis. The CubeSat's solar arrays harness energy from the sun to supply the electric power needed to operate the miniature electrolysis system. These gases are more energetic fuels than water. Burning hydrogen and oxygen gas in a rocket nozzle generates more thrust than using unsplit liquid water as propellant. This strikes a better balance between performance and safety for spacecraft propulsion, meaning CubeSats will get more bang for the buck. What's new is that this system uses water as the fuel in an energetic way, with an inherently safe system. This mission will show that we can use water electrolysis in a rocket engine in space. That's pretty cool, isn't it? Water is an inexpensive green resource for propulsion, non-toxic and stable. Green propellants like water are easier to handle, cheaper to obtain, and safer to integrate into spacecraft. The use of traditional high-performance rocket fuels for CubeSat propulsion systems are avoided because the onboard presence of such fuels would increase mission risk to other payloads and the launch vehicle. The inability to use these fuels limits performance for small spacecraft propulsion systems. Water is the safest rocket fuel I know of, said Meyer. A low-cost, effective propulsion system. PTD-1 spacecraft being loaded in a CubeSat deployer before flight. The CubeSat used in NASA's Pathfinder Technology Demonstrator-1, or PTD-1, mission being loaded into a CubeSat deployer. The PTD-1 spacecraft is a 6-unit CubeSat, comparable in size to a shoebox. Its flight demonstration, lasting 4 to 6 months, will verify propulsion performance through program changes in spacecraft velocity and altitude executed by the water-fueled thrusters. The mission will show that the safe, low-cost, high-performance propulsion system works in space and will pave the way for operational small spacecraft missions. Flight qualification and demonstration of this technology increases small spacecraft mobility and capability for use in future science and exploration missions. This technology could be applied in future deep space missions using water resources found off Earth, such as from comets or the Moon and Mars. As always, thanks for watching. We put a lot of effort to make this videos for you guys, so if you like this video, make sure give it a thumbs up, it motivates me to keep making these videos, and don't forget to subscribe our channel. Stay tuned and be safe, be healthy, God bless you all.